AI can be applied for good in many different industries. One example is precision agriculture. AI can help recognize diseased crops and optimize treatment. This can increase crop yield and save farmers money. Using OpenShift AI, we'll train a computer vision model for drones to detect unhealthy crops. Then, we'll train a second model for tractors to treat the fields using the shortest path and then demonstrate it in a fun game form. In OpenShift AI, we have defined a data science project. Let's go to the Workbenches section and start our Intelligent Agriculture workbench. Once our workbench is running, we can open it. Here are samples of images of healthy or ill crops that we want to train a model to recognize. Let's train the model and see the results of the training. We can now save our model. Back to the OpenShift AI dashboard, we can easily serve this model. It's a simple configuration, indicating where the model has been saved and how we want to serve it. We then get an inference endpoint that we can directly query. Now, let's start another workbench to work on tractors' path optimization. Here we have modelized an area with obstacles in the middle and programmed an algorithm to find the shortest path between 2 points. We also have an algorithm to find the best solution to visit all points with a fixed number of tractors, 10 in this case. Let's have a look at the application we will use to simulate our intelligent farming. On the top left, we have the drone that will do the crops survey. It is stationary at the moment. We have different types of crops in our fields: wheat, potato, and corn. Some fields are healthy. They have a green background. Some are ill with a gray background. If you click on a field, you can see its status in the bottom right section. You can change this status at any time if you want. Finally, we have our tractors, each taking care of a specific type of crop. Orange for potatoes, green for corn, and yellow for wheat. As you can see, the tractors are in constant communication with OpenShift. That's where all the information sent by the drone is processed using the image recognition model and the pathfinding algorithm. The tractors will get their instructions, which fields they have to visit, they can do a maximum of 5 at a time, and the optimized path they must take. They will then come to the barn to reload treatments or nutrients and wait for their next assignment. Let's run the simulation by clicking on the Start button at the bottom left. The drone is now flying over the fields. Using our model, an assessment is made on the status of the crop. The result is then displayed in the upper right section. If the field has to be treated, it will be marked with a yellow band. After some time, we can see that the tractors are getting their assignments and begin to treat the fields, following the path they have been assigned. This is how AI technologies can help increase crop yield while being mindful about resources like water or pesticides and save farmers money. I hope you enjoyed this demo of AI-assisted farming using elements of Telco 5G, edge computing, and computer vision, all orchestrated on OpenShift with the help of OpenShift AI.